this particular part, we'll be learning about what is known as a ticker tape method. This is a kind of a new method to measure the time. Also, we'll try to learn a little bit more about the different ways of finding the errors. So this is what we are going to identify. Obviously, to understand more about errors, we'll be using some concepts of differentiation. So please stay tuned. This is going to be very, very important part. Now coming to the one of the most important parts. I haven't written down anything, that's the reason. Okay, here's a blank piece of paper. Now, you know that the time period of any particular pendulum, if I say, so time period is given by 2 pi root over L over G, right? Now, if I want to say how much is the variation in the time period taking place as a factor of the change in length and the acceleration due to gravity at a particular point, okay? So what we do, we basically vary this. So how do we vary this? Let's try to explain this. So this can be written as 2 pi L raised to the power half G raised to the power minus half, yeah? Now let's vary this. So if I vary this, first of all, I'm going to vary with respect to the length. Okay. So if I vary this, so what will I get? I'm basically differentiating it with respect to the length. So if I get it, so I'll get half L raised to the power minus half, and then I'll have a factor of delta L G raised to the power minus half remains as it is. Okay. Then you have the factor 2 pi. You have L raised to the power half. Then you have minus half factor coming out, and then what you get, you'll get G raised to the power minus 3 by 2, and then you have the factor of delta G. Clear? So delta T is known to us. Now let's try to divide this. So delta T divided by T, so this will be given by 2 pi, factor of half can be taken out, so I'm not taking that into consideration as of now. So we'll get L raised to the power minus half G raised to the power minus half delta L plus 2 pi. I'm just taking a positive sign here, I'm not taking the negative sign. I'll tell you why am I not doing that. So 2 pi, then you will have L raised to the power half G raised to the power minus 3 by 2, and whole divided by, you will have a factor of 2 pi L raised to the power half G raised to the power minus half, and then you also have the factor of half. Now please understand, here we are trying to understand the variation, right? We are not trying to find out the absolute variation, we find the range, that is what can be the maximum possible value of the variation that can take place, okay? That's the reason we are not basically taking into account this minus sign. This minus sign is not going to play a role because we are trying to find out the maximum value. Maximum value is basically from the additions, yeah? Okay, now let's try to understand the factor of 2 pi gets cancelled throughout, right? I missed the factor of delta G here. So now what can be given? So from the first term, G raised to the power minus half goes, so you'll be left with delta L divided by, you will have the factor of L. From the second term, you will get delta G divided by G. So you will get what? Delta T divided by T. This comes after this. So now if you would like to find out the percentage change, so percentage change in the time period, so you multiply it by 100. So this is going to be given by delta L by L into 100 plus delta G by G into 100. If you are given these values, let me change the color. You are given the percentage change in the length, you are given the percentage change, this is G here in the denominator. You are given the percentage change in the acceleration due to gravity, and you are given the percentage change in the length. So that from there you can find out how much is the percentage change taking place in the time period of the pendulum, right? So this is a very, very important thing, right? Hopefully the steps are clear. Now if I have to summarize what all we have learned in this particular part, the meter rule and half meter rule are used to measure the lengths accurately up to a distance of 0.1 centimeter. Please understand, 0.1 centimeter is the least count. Then vernier calipers are used to measure lengths to a precision of 0.01 centimeters. Micrometer are used to measure the length to a precision of 0.01 millimeter, that is 0.001 centimeters. Now this is a very, very important thing. What is a parallax? Parallax is if you are trying to measure something and you are moving from the left to the right, that is you are trying to measure it from the left or from the right, you are not doing a correct measurement. As you are going to do a correct measurement only if you look from the top. Only then you are going to get the correct value of the measurement. So in this particular case, there is an incorrect positioning of the eye and the object is not being at the same level as the marking on the scale. In that case, in either of these cases, there are going to be parallax. Further, there is going to be zero error. Whenever you are trying to measure something, for example, you use anything, for instance, you have a galvanometer, okay, and even when you have not connected, the galvanometer is still showing not a zero value, either it is less than zero or it's more than zero. In that case, you have a zero error. You need to rectify that. Else, you need to measure how much is the value that is showing, and so based on that, you need to either add or subtract that value from the resultant values that you get. But it's always better to get rid of that zero error. Further, we already found out how much is the error. So error of a time period. So time period is basically the time for one complete swing of the pendulum. That is, when the pendulum moves from a point, it goes to another, comes back to the original point of starting its oscillation. So that whole time period is known as the time of the oscillation. Further, as the length of the pendulum is increased, the period of the oscillation is also going to increase. Why? We already know the formula. T equals to 2 pi root over L by G. So assuming the acceleration due to gravity is constant wherever in measuring, so effectively T is proportional to square root of L. So you increase the length, the time period of oscillation is going to increase. Okay, so I've tried to summarize this and try to put it everything so that you understand what all we have learned. So we have physical quantities. So these are physical quantities. What all it is made up of? It's made up of, let me change the color. Okay, so it is made up of numerical values and suitable units. The physical quantities include base quantities and derived quantities. It may be either a vector quantity or a scalar quantity, right? Base quantities include length, mass, time, electric current, temperature, amount of substance, it can be candela. Further, why do you use base quantities? When you measure it. Measurement can be of length, mass, anything, or for time. Then the base quantities, it can be small or big, it can be the length, or let's say the solar length, you can say. So it is based on the light years. So in that case, you need to use prefixes. The prefixes can either be small or it can be huge, right? Based on that, we figure it out. Now let's move on further and try to understand some questions. So moving on to the first question. Physical quantities, we need to understand whether these are true or false. Physical quantities must have both magnitude and unit. Obviously it's true. Base quantities and base units are the same. No. Base quantities are the length, mass and time. Units are meter, kilogram, second. So they are not the same. Derived units are not physical quantities. Again, they are physical quantity, but they have been derived. They are not the base quantities because they are not the prime quantities. You derive it from the base quantities, so they are still physical quantities. SI unit for length, mass and time are meter, gram and second. Wrong. It's kilogram. This should have been kilogram. Only then this should have been correct. Prefixes are used to express big numbers only. Wrong. You can also have very, very small readings. In that case as well, you use the prefixes. This is wrong. Further, non-parallel vectors cannot be added arithmetically. That's true. Because when the vectors are moving along different directions, you cannot add them up. Only when they move along the same direction, then you can add them up. Right? So this is true. Parallax is due to the incorrect positioning of the eye when taking readings. Obviously, we have just learned it. It's true. Zero error can be taken by more readings. No. Zero error cannot be rectified because in all the measurements, you are going to still get the zero value of the error. In some experiments, you can get rid of the zero error, but obviously that's going to be only special cases, not all cases. So it's not going to be true. A reading should be recorded as 10 centimeter when use 10.0 centimeter when using a meter rule. The meter root has a minimum value of 0.1 centimeter. That's the least count. So you can write down the reading as 10 centimeter. You cannot go further below the decimal points. So this is true. The time period of pendulum increases with length. Obviously we have just learned it that T is equal to 2 pi root over L by G, and therefore the time period is going to be proportional to square root of L. So this is going to be true, right? Okay, let's move on further. So these are questions that you need to understand and say. A boy measures the length of the table and says that it is 1.5153 meter. First of all, this is not wrong. This is not definitely wrong, but it depends upon which system of unit that you are measuring. If you are using a meter scale, then you cannot measure to such high an accuracy, right? Further, since you are measuring the length of a table, you cannot measure it using a vernier caliper or a screw gauge, because that measures very small values. So small values can be measured up to very high accuracy, but using a meter scale you can at the most go up to 0.1 centimeter in units of 0.1 centimeter. So that means this particular part of 153 is not logical. You cannot measure it using the system of units or using the apparatus that we have discussed. So what do you think he used? He may have used very precise instruments that are definitely possible. They are electronic instruments that are possible using that, but definitely it cannot be using a meter scale. If he had measured it with a measuring tape marked in millimeters, write down what would have been a reasonable answer for him to give. So this is if he would have measured in millimeters. Now you know that 1 meter has 1000 millimeters, yeah. So therefore 1.5153 will have 1.5153 into 1000. So if we get rid of the decimal, so we'll get 1 2 3 4. So if we have this, so 3 zeros goes, so you'll get 1515 if we had been measured in millimeters. Okay, so this many millimeters that we have. Okay, fine, let's move on. Which of the following quantities is not a base quantity? Length, yes it is. Temperature, yes it is. Weight is not, because weight is mass into acceleration due to gravity. So it's not a base quantity. Electric current it is. Okay, which is the longest length? Now 3.54 into 10 raised to the power 3 millimeters. If you change it into meters, so this becomes 3.54 meters. Then 3.54 into 10 raised to the power 5 centimeters. You have 10 raised to the power 2 centimeters. So this becomes 3.54 into 10 raised to the power 3 meters. Further, you have 3.54 into 10 raised to the power 2 kilometers. So this is going to be given by 3.54 into 10 raised to the power 5 meters. And then this is 3.54 into 10 raised to the power 4 meters. So obviously which one is the longest? It's quite obvious that this is the longest. Hopefully you understood about this.